हेलो स्टूडेंट्स, तो मेरा नाम है प्रशांत सर और आज हम क्लास 12 फिजिक्स के इलेक्ट्रोमैग्नेटिक इंडक्शन चैप्टर के कुछ एमसीक्यू क्वेश्चंस देखेंगे। तो चलिए शुरू करते हैं। क्वेश्चन नंबर फर्स्ट, द लॉ दैट द इंड्यूस्ड ईएमएफ एंड करंट ऑलवेज अपोज द कॉज प्रोड्यूसिंग देम इज ड्यू। ठीक है, सो लॉ, ऐसा लॉ जो कि क्या करता है, इंड्यूस ईएमएफ एंड करंट उसको अपोज करने के लिए, उसको अपोज करने का रीजन है कि उसका जो उससे वो जिससे बना हुआ है, तो कॉज प्रोड्यूसिंग देम। तो ऐसा कौन सा लॉ है? ठीक है, तो जैसे हमें पता है कि फैराडेज लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन, उसमें क्या बताया है कि चेंजिंग मैग्नेटिक फ्लक्स प्रोड्यूसिंग ईएमएफ। लेकिन जो ईएमएफ प्रोड्यूस हो गया है वो किसकी वजह से हो गया है? मैग्नेटिक फ्लक्स को चेंज करने की वजह से। और जो ईएमएफ और करंट प्रोड्यूस हो गया है मैग्नेटिक फ्लक्स को चेंज करने की वजह से, तो वो जिसने उसको बनाया है, मतलब जिस मैग्नेटिक फ्लक्स से वो बना है, उसी को ये अपोज कर देता है। और ये जो सब कुछ बताया है वो लेंज लॉ ने बताया है, क्योंकि फैराडेज लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन में उसका जो साइन है वो निगेटिव इसलिए बताया है क्योंकि लेंज लॉ ने उसका रीजन बताया है। सो हियर द ऑप्शन डी इज द करेक्ट आंसर। आप वीडियो को पॉज करके उसका आंसर चेक कर सकते हो। ठीक है, तो हम करते हैं शुरू क्वेश्चन नंबर 2। इफ करंट इन अ कंडक्टर इंक्रीजेस, देन अकॉर्डिंग टू लेंज लॉ सेल्फ इंड्यूस्ड वोल्टेज विल बी। सो करंट इन अ कंडक्टर इंक्रीजेस, कंडक्टर में करंट बढ़ जाता है। अकॉर्डिंग टू लेंज लॉ सेल्फ इंड्यूस्ड वोल्टेज विल बी। व्हाट अबाउट द सेल्फ इंड्यूस्ड वोल्टेज? सो फर्स्ट, aid the increasing current, B tend to decrease the amount of current, C produce current opposite to the increasing current, D aid the applied voltage। तो इसका आंसर है प्रोड्यूस करंट अपोजिट टू द इंक्रीजिंग करंट। मतलब जैसे करंट बढ़ जाएगा उसमें कॉइल में फ्लो होने के, तो उसको अपोजिट करंट उसमें प्रोड्यूस हो जाएगा। और वही तो लेंज लॉ में हमें बताया है कि अगर हम करंट बढ़ाते हैं, करंट चेंज करते हैं, करंट इंक्रीज करते हैं, करंट चेंज करते हैं, तो उसकी वजह से ऑपोजिट करंट प्रोड्यूस हो जाता है, ऑपोजिट ईएमएफ प्रोड्यूस हो जाता है। सो द ऑप्शन सी इज द करेक्ट, प्रोड्यूस करंट ऑपोजिट टू द इंक्रीजिंग करंट। उसके बाद क्वेश्चन नंबर 3, एज पर फैराडेज लॉ ऑफ इलेक्ट्रोमैग्नेटिक इंडक्शन एन ईएमएफ इज इंड्यूस्ड इन अ कंडक्टर व्हेनेवर इट, ऑप्शन ए कट मैग्नेटिक फ्लक्स, B lies perpendicular to the magnetic flux, C lies in a magnetic flux, D moves parallel to the direction of magnetic. So question is that as per Faraday's law of electromagnetic induction, an EMF is induced in a conductor whenever option A is the correct, that is a cut magnetic flux. Now question number 4, an EMF of 16 volts is induced in a coil of inductance 400. The rate of change of current must be. So in this question, what are the given quantities? First is EMF is given, and the EMF it is a 16 volt. So you can see EMF it is a 16 volt. It is induced in the coil. एक coil है, उस coil में EMF induce हो गया है। ठीक है, तो EMF कितना induce हो गया है? 16 volt. And the inductance is also given. It is a 4 Henry. So we can write here L is equal to 4 Henry, and we have to find the rate of change of current. It means that di by dt. So we have to find di by dt. So we have formula EMF, it is equal to the inductance times di by dt. So we can find the rate of change of current, and it is EMF divided by inductance, which is equal to di by dt. So we will put the value of EMF, that is 16, divided by the value of inductance, it is a 4. 4 dividing to the 16 will give us 4, and that will give us the it is in unit of ampere per second, because it is a rate of change of current with time. So the option A is the correct. Now the next question, question number 5. A 508 tons of solenoid develops an average induced voltage of 60 volt. Over what time interval must a flux change of 0.06 Weber occur to produce such a voltage? आप वीडियो को पॉज करके आप कैलकुलेशन कर सकते हो एंड यू विल एबल टू ट्राई टू फाइंड द आंसर. ठीक है, और आप आंसर चेक कर सकते हो. तो मैं आंसर लिख देता हूं. हमारे पास गिवन है 508 टन्स ऑफ अ सोलेनॉइड. ठीक है, तो एक देखो ऐसा एक सोलेनॉइड है. ठीक है, और इस सोलेनॉइड के कितने टर्म्स है? 508. ठीक है, सो नंबर ऑफ टर्न्स इट इज गिवन n इज इक्वल टू 508 टर्न्स ऑफ अ सोलेनॉइड डेवलप्स एन एवरेज इंड्यूस्ड वोल्टेज. तो ईएमएफ जो है वो प्रोड्यूस कर देता है, वो कितना है? 60 वोल्ट है. ओवर व्हाट टाइम इंटरवल, मतलब हमें क्या करना है? डेल्टा टी फाइंड आउट करना है. एंड मोस्ट फ्लक्स चेंज इज गिवन, इट इज इन वेबर, एंड व्हाट इज दैट? इट इज अ डेल्टा फाई. Okay, and occur to produce such a voltage. Now we have to find delta T. We have given the EMF, isn't it? और जो कॉइल इसमें कितने नंबर ऑफ टर्न्स है? 508 टर्न है. तो हमारे पास फॉर्मूला है EMF, इट इज इक्वल टू द नंबर ऑफ टर्न्स मल्टीप्लाई बाय d phi by dt, which is the Faraday's law of electromagnetic induction. That is, changing magnetic flux produces EMF. So in this question we can also write this n into d phi by dt, means rate of change of magnetic flux with respect to time, that we can write delta phi by delta t. So changing flux with change in time. So here we have to find the this delta t. So we can write delta t, it is equal to the n times delta phi divided by EMF. So I will just put the values. N is the number of turns, it is a 508 given. Delta phi here it is given 0.06. I will put this value 0.06 divided by the EMF. It is given here it is a 60 volt, so I will put this value 60. So now I just have to calculate it. 508 multiply by, I will shift this decimal point towards the right side by 3 decimal places, 1 2 3, then it will become 60 into 10 to the power minus 3, and the denominator 60 as it is. Now cancelling the numerator and denominator 60, we get the 508 multiplied by 10 to the power minus 3. So it will be 10 to the power minus 3 multiplied by 500. So shifting decimal points, as there is a 10 to the power minus 3, so we have to move this decimal point towards left side by 3 place. So it will be 0.508, and it is a value of time, so it will be in second. So we can take the options. Now you see that here option is the 0.5 second. Option B is the correct option. Now let's see question number 6. A coil induces 350 millivolt when the current changes at the rate of 1 ampere per second. The value of inductance is. Now we have given the inductance of we have to find the inductance. Okay, actually we have to find the inductance, that L we have to find. So what is the value of L? What is given? This 1 ampere per second means is a rate of change of current with respect to time, that is given. It is 1 ampere per second. And also the this it is in millivolt, it means that it is the voltage, isn't it? And its EMF, it is equal to 350 millivolt. Now we have to find the inductance. So we have formula EMF, it is equal to inductance multiplied by di by dt. So here we have given this value, and we have to find the L. So L is equal to the EMF divided by di by dt. So we will put the value of EMF, it is a 350 millivolt, means 10 to the power minus 3 volt, divided by the value of rate of change of current with time, it is a 1 ampere per second. So this is the answer in Henry. So 350 we can convert in millihenry, it is 350 millihenry. So we can pick the option B is the correct answer of this question. Now question number 6. Question number 7. A conductor 2 meter long moves at right angles to the magnetic field of flux density 1 Tesla with a velocity of 12.5 meter per second. the induced EMF in the conductor will be. So we can see from this question, we have to find induced EMF, isn't it? We have to find induced EMF, and we have given the length of a conductor. It is a 2 meter long, and which are moving at the right angles to the magnetic flux of flux density with the magnetic field 1 Tesla. It means that this is the value of V, and the velocity is also given. It is equal to 12.5 meter per second. Now, how do we calculate the EMF from this question? So you can pause the video and check the how can we calculate the EMF. So we have a formula that if there is a conductor and which are moving at right angles, okay, having the length L. So we have formula in terms of EMF. EMF, it is equal to the VLV, where V is the magnetic field, L is the length of the conductor, and the velocity of conductor V, it is so all these parameters are given. So we will just put the value magnetic field V, it is 1 Tesla, multiply with the length in 2 meter and the value of velocity in 12.5 meter per second. So you have to remember here that the all values should be in SI units. So multiply by 12.5 gives us 25 and is a EMF, so it is in volt. So we can check the option. Option C is the correct, that is a 25 volt. Now question number 8. An average voltage of 10 volt is induced in a 250 turns solenoid as a result of a change in flux which occurs in 0.5 seconds. The total flux change is. So we can see the what are the values given here. The EMF is given, it is a 10 volt. So this is the value of EMF, and which are induced in a 250 turns of solenoid. Okay, so you can see this is the solenoid and having the 250 number of turns. N kitne hai? 250 hai. So the time is also given, and we have to find the total flux. Okay, flux change we have to find. So how can we find? We can pause the video and try to find the answer. So here is the solution. We know very well that this EMF, it is equal to the N times delta phi by delta T. Okay, so changing flux with respect to time. This multiplied by the number of turns of this solenoid is equal to the EMF. And here in this question we have to find the delta phi, that is a flux change. Okay, so we have to find delta phi. So time is also given, it is delta T, and the number of turns is also given, isn't it? That is the 250 number of turns is there. So we can find delta phi from this equation. It is EMF multiplied by delta T divided by N. So we will put the value of EMF, it is a 10 volt, multiply the value of time, it is given here 0.5 divided by the number of turns, it is a 250. So 0.5 multiplied by 10 gives us 5 divided by 250, and 5 is dividing 250 will give us 50. So we get 1 upon 50. So delta phi, it is equal to, we can write it is a 100 into 10 to the power minus 2 divided by 50 for easy calculation. 52 is 10, 100. So 2 multiplied by 10 to the power minus 2, that is 0.02 Weber. So this is the answer of the change in magnetic flux. So that you can see the options is the option C is not there. Option D is the correct answer. Okay, this is the option D is the correct. Now question number 9. Current changing from 8 ampere to 12 ampere. So we can find the changing current from this question. That is this change in current in 1 second. 1 second, the current is changing from 8 ampere to 12 ampere. And induced voltage, it is a 20 volt in a coil. And the value of inductance means we have to find the value of L, and the voltage EMF, it is given. Change in current with respect to time, which is a 1 second time is given, and currently changing from 8 ampere to 12 ampere. So we can find the di by dt. change in current with respect to time. It is a 12 minus 8 divided by 1 because 1 second में हमें calculate करना है. So 12 minus 8, it is a 4 upon 1, it is a 4 ampere per second. So change in current with time, that also we have calculated EMF. It is given 20 volt. We have to find the inductance of the. So how do we calculate this? We can pause the video and try to find the answer. So you can see here EMF, it is equal to inductance, okay, multiply by di by dt. So we can use this formula of the inductance, and we can find the value of L. It is EMF divided by di by dt. So value of EMF, it is 20 volt, and di by dt just we have calculated is a 4. So 4 5 is 20. So 5 Henry is the answer of this question, and we can say option C is the correct answer. Now question number 10. Reversing the field or the current will reverse the force on the conductor. The statement is true, false. Only reversing field reverses the force on conductor. Only reversing current reverses the force on the conductor. Basically, by reversing field or by reversing the current, because of both the force on the conductor, the reverses the force on the conductor by reversing field or by reversing current, or both. Because of that, the force on the conductor is reversing. So it means that this option is the correct answer. It is a true this statement given. Okay. So the next MCQ questions we will see in next video.